This is a proof without words to prove the formula that 1 squared plus 2 squared up to n squared is n times n plus 1 times 2n plus 1 over 6. And the way it works is, on the right hand side I have, this is 3 times 1 squared. Here are 3 2 by 2 squares. And here's 3 by 3 squares. And this last one I'm just going to say is 3n squares. Even though it's specifically 5 by 5, I'm just going to call it n. So the sum of all these is 3 times 1 squared plus 2 squared up to n squared. Now, if I reassemble all these pieces on the right of this line here, I can reform them into the pieces on the left. Like you could kind of see this little square is here, and this one is over there, and this little tiny guy is up there. So you can kind of see the idea is that all these little pieces over here that make up these pictures are reassembled in a different way on the left. Well, what do we see on the left? We see a lot of n squares. Specifically, I see 1, 2, 3, 4, 5, 6 of them. N was kind of 5 in this case, so it's n plus 1 of them. So I have n plus 1 times n squared. But I also have these little guys left over, the 1, 2, 3, 4, 5. So I also have a 1 plus 2 up to n. So let's see what happens. If these two things, if the left and right are the same, let's look at what happens when I look at the two expressions. So the right side is 3 times 1 squared plus 2 squared. The left side is n plus 1 times n squared plus 1 plus 2 up to n. We have a formula for that. That's n times n plus 1 over 2. I'm going to get a common denominator here. And if I divide both sides by 3, this becomes a 6. So I'm done, except that formula maybe doesn't look so familiar to us. So what I can do is I can factor out, you see how there's an n plus 1 here and an n plus 1 here? If I factor that out, I get 2 parentheses n plus 1. Inside the parentheses, I factor out the n plus 1, and I get 2n squared plus n over 6. But I could factor an n out of that and get 2n plus 1. And this is our famous formula for the sum of the squares.